Welcome back, everybody. All right, today in Math 1, Foundations of Math, we're going to talk about something called function notation. Some of you may have done this in the 8th grade and seen it already, but some may not have. I put it in the review section because our text, our curriculum starts off using this notation right away, and it's expected that we learn it. Now, it's part of this year's job anyway, so we're going to go ahead and start on it now so we can go ahead and pick it up and perfect it as we go along. But before we do this whole thing with this function notation, I want to show you something that you can kind of relate it to, and it's something you already know. Most of you will understand this. You've seen it before. Remember the y equals mx plus b stuff you were taught, and you were saying, hey, well, y equals mx plus b, this is all ordered pairs that satisfy this equation. That's what this line is. It's made up of infinitely many ordered pairs that make this a true statement, right? It also means it's got a slope of 2, y-intercept 3, and all that stuff. This is a function, right? So function notation is a lot like completing ordered pairs. Now, you've done this before, but I want to bring it up and show it to you. If someone said, if x is 2, what is the value of y? Well, it's right here. If x is 2, well, if I can get it directly on it, y is 7. That's absolutely true. If x is 2, y is 7. All right, now if you had to do it by hand, let's say like this. Y equals 2x plus 3. Well, that says start the ordered pair. Well, it's got a 2. And to complete it, you have to plug 2 in for x to find out what y is. 2 times 2 plus 3. Last time I checked, that's 4 plus 3. And I know we're good enough to call that a 7. So that's how you complete ordered pairs. And that's how this works. Now, let's go to function notation, and we'll show you they're very similar things. All right. Intro to the notes of function notation. Okay, so function notation replaces y with f of x. All it does, I'm using the same function we just had. For example, y equals 2x plus 3. To write that in function notation, they just take that y away and replace it with f of x. And here's how you read this. This is a function whose name is f. The function's name is f. You can call it f. And when you say f, it's equal to 2x plus 3. So they're equivalent things. And f is a function of the independent variable x. All right, so what you see inside these parentheses, that just tells us what the variable is that we're working with. You might be looking over here going, Mr. House, I know it's x. I'm looking at it. Well, they can have more than one variable over here, or more than one letter. Then you would know that the variable that we're referring to is x. Now, people that don't know any math will call this f times x. That is not what this says. This says f is a function of x. I should have wrote that in there too. All right. Why would anybody want to name a function is the question now. And the answer is, oftentimes functions need a name. And sometimes context makes that make more sense. This makes more sense when a function has context. For example, d equals rt is a function that gives us distance for some amount of time. It's a distance function. We've seen this before. So it gives you a distance for any input of time t. In this case, the function could become, now notice here they're not using function notation, but down here I do. So well, d of t. This reads d is a function of t. Yes, distance is a function of time. The name d reminds us of what the function does. That's why they named it d. It would make sense to call this g, would it? I mean, because we're really talking about the word distance. So we're going to use something that's friendly that reminds us of what this thing actually does. And it takes in a time and puts out distance. For example, if you're driving a car 50 miles an hour, that's a rate, that's what r is. In 2 hours, you'd go 100 miles. So one way to write this thing would be d of t equals, if you had a constant rate, we're saying the car going 50 t. Right? And now if you plug in a time, like 2, you get 100. And that's how these things work. All right, before I get too long-winded here, let me get down to the easy part. Explaining the need for it is sometimes more complicated than using it, because it's not very hard to use. It's exactly what we just did, completing ordered pairs. All right, evaluating a function. That's the big job here. Something we need to be able to do. We need to be able to do it very, very well. Evaluating a function is very much like evaluating an expression. You've done that in those previous delta maths. Plug stuff in, right? Consider the function f of x equals 2x plus 3. That's the one we just looked at. All right, here's how you read this. F of 5. That does not say 5 times f. That's a mistake. F of 5 means find the function value for x equals 5. So all we need to do is substitute 5 for x. Oh, I need to correct that. Some say plug in 5 for x. That's how a lot of people say this. So this thing would look like this. I'm going to just f of 5 equals 2 times 5, just like you saw me do on that other in that other little thing, the other template we used. So this becomes 10 plus 3, which is 13. And that's how you evaluate a function. You just plug numbers into x. All right, and this gets me to our last case here. They can become more complicated with negatives and multiple expressions of x with different powers. So in this case right here, f of -1 means plug that -1 in to every x you see. Right? F of -1 means -1 goes there and there. Now what I want you guys to do is use parentheses when you do it. So your expression should turn out looking like that. F of -1 equals. Notice I use parentheses on these -1s. -3 times -1 square it minus 2 times -1 plus 5. And for this example, I'm going to go ahead and put it into my calculator because I'm hoping that you guys start using these calculators because that's the only way you're going to become good at it. And you need to be good at it. So let's plug this thing in here and see what we get. So I got, I can't do it that way. -3, parenthesis, I can't emphasize it enough, use them. -1, parenthesis, square it. It's a shortcut to squaring. And it says minus 2 times -1 plus 5. And that value is 4. So we get, it's 4. Now real quick, I want to go in here and show you this is exactly the same thing we were just talking about. Delta Math, not Delta Math. This program does not mind you using f of x notation. We got -3x squared minus 2x plus 5, and at -1, if I can get it, zoom in there, there it is. Function value is 4. Now I don't want you graphing these to evaluate functions. I'm not telling you to do that. I'm just illustrating that it's the same thing. Okay? So basically it's completing an ordered pair. Again, the notes are right here for you. It's already linked. It's just getting longer and longer, and pretty soon we'll be done with them. So I hope this video is good enough to get you going with evaluating functions. Oh, real quick, back to the graph. The last example, if somebody tells you to find what is f, now it's going to give me an error message. That's okay. F of 0, say. Oh, it does give you 5. It tells you what it is. Well, another way to do that is you would come along here to 0 for x and go up till you hit the graph. You got problems like that to do in Delta Math as well. Okay? So I didn't know it would do that. That's something I just learned in this video. Huh, that's pretty cool. So find it on the x-axis, go up to where it hits the curve. And that's what this example down here does. Ah, look at that. I need to fix that. Let me just put that all the way down there. All right. Evaluating functions from a graph. So f of -2. Looking at this graph right here, we go to x is -2, and we go up till we hit the graph. And honestly, it looks like that is at 5 to me. So f of negative 2 equals 5. And that's how you would do that one. All right. Hope this was helpful, and I know it got a little bit long, but that should do it. Good luck on the homework.